The magic number is 8. These are Lewis dot structures. They're going to give away those valence electrons. Very low ionization energy. Here, take my electrons. This lesson is about bonding. Chemistry's starting to get good. We're going to put together all these things that we've been learning and talk about bonding. So why and how do atoms bond? Did you know that most atoms are not stable and they cannot exist as an atom alone? You will never see an oxygen atom just hanging out by itself. Never. So how do they become stable? Well, they will do one of three things. They will gain or lose or share valence electrons. So everything that we've learned about ionization energy, electronegativity, valence electrons, it's all going to pan out when we talk about bonding. Now, the way we note where valence electrons is with a Lewis structure. You may see it called Lewis dot or electron dot structure. So we're going to represent every valence electron with a dot. Now the max you can have is 8 dots. 8 valence electrons is all you can have. And do you remember why? How many electrons can go in an s orbital? 2. How many electrons can go in p orbitals? 6. What's 2 plus 6? 8. The magic number is 8. These are Lewis dot structures for every atom in period 2. So look at your periodic table. Lithium's on the left, neon's on the right. Now notice neon has 8, and noble gases all have 8 with the exception of helium. So helium, I'm going to just draw him right here. He's got only 2 valence electrons, and that is good enough for him. That's all he needs is those 2 electrons. So everything right below that, like for example, if I were to draw sodium, he also just has 1 dot, 1 valence electron. And guess what? Potassium, 1 valence electron. So remember, everybody in a group has the same number of valence electrons. They're going to look very similar. Now, here it is, the octet rule. What does octet mean? Right? It's a group with like 8 musicians or something. Octet means 8. And so the magic number here is 8. So here is the rule. Atoms will gain, lose, or share electrons until they get a full set, and that is 8. Except for helium. Helium and hydrogen only need 2. So I will say this, except hydrogen and helium, and that would be only 2. So what they're all trying to do is achieve the electron configuration of a noble gas. 8 valence electrons is super duper stable. And noble gases don't bond because they already have a full set of valence electrons, which is 8. Let's look at our periodic table, and you may even want to label this up. How many valence electrons do the elements in the first column have? They all have 1 valence electron. The next group, 2. Skip the transition metals. We're going to go over here. 3, 4, 5, 6, 7, and look at these guys. Except for helium, they all have 8. This you need to memorize or write on your periodic table. How many valence electrons? And here's the cool thing. Elements with 1, 2, or 3 are typically going to give them away. They're going to give away those valence electrons. Very low ionization energy. Here, take my electrons. Elements on the other side with 5, 6, or 7, hey, they're getting closer to 8 electrons. And so they are only going to have to go out and get 3, 2, or 1 electrons. So these elements are going to gain electrons. Right? So if they only have a few, they're going to give them away. And when they do that, they'll be stable. The elements on the other side that have more valence electrons will need to get a few to become stable.